So a body continues to be in its state of rest, or uniform motion. Right? Until when? Until and unless an external unbalanced force acts on it. Right? So we are looking at a body continues to be in a state of rest or uniform motion until and unless an unbalanced force acts on it. Right? External force. We have one more word coming here. There are two things. What is unbalanced force? We are seeing if the net force is zero, they are balanced forces. If the net force is not zero, it is unbalanced force. Now, what do you mean by an external force? Yes, can anyone tell me what is an external force?
If I'm not wrong, a force which is not applied by the object pushing it, but from some external source. Like, for example, if there are two boxes and we push the second box and the first box moves, then we are the external force. If I'm not wrong.
Okay, that's a good.
When the force isn't being applied by the body itself, but by a foreign body outside of it.
Yeah, precisely.
Okay, yeah, that's also accepted. Yes, Rishit, you want to say something?
No, sir.
Okay, fine, thank you. So, I got a couple of answers. One is what? A force which is applied from an external source. So I'll just give you an example, right? You should tell me whether that force is external or internal. Now, so I have a box. Let's say there is a box. So let's say there is a person, who is pushing the box. So now see here. So let's say there is a person who is pushing a box. So he is pushing a box, applying a force F on the box. Now, is the force applied by the person external or internal? Is the force applied by the person
internal
force or internal?
Sir, I say internal.
On the box.
Even I say internal.
Internal.
Sir, external force.
External force. Who is that? Dhye or Veda?
Veda.
Veda, external force. Okay, fine. Yes, go ahead.
It's external because the object you're pushing, you're pushing it. The box isn't moving by itself. If it was an internal, the box would be moving by itself. But since it's someone pushing it, it's an external force.
Okay, understood. Yeah, Veda, you can tell me. Veda, why do you think it is external?
Sir, because the particles itself are not moving, there is an other force which is acting so that they move.
Okay, so there is other force which is acting so that it moves. So that's external. You also agree with Kavya. Great. Now see, let's answer Kavya's question whether it is external or internal. Now, both it can be considered as external or internal, depending on what we define as a system. You getting it? So the people who said external, they're right. The people who said internal, also they're right, because we didn't define what is our system. Now let's see. If my system is only box, then force is applied by an external part on that. In that case, what is the force? That is external, right? Or if my system is only man, this is my system, then also what is happening? The force is applied on an external body. So in that case also it is external. If my system is both man and box, then what is force? Force is internal. I hope you're getting it. Is that clear? So what decides whether a force is...
I didn't get it. I didn't get it.
Okay, let me explain this. So what decides whether a force is external or internal? So the consideration of the system decides whether the force is external or internal. I hope it is clear. So if I assume that only the box is system, then the force applied by the man on the box is external. Similarly, if I find only man to be system, then the force applied by the man on the system is external. But if I take both box and man as system, then the force applied by man on the box is what? Internal. Okay. Let me give you another example. So let's say I push this board like this. I'm pushing this board. So the force applied by me on the board, is it external or internal? I'm pushing this board. So the force applied by me on the board, is it external force or internal force?
Sir?
It's external.
So if I'm pushing the board, what is happening? The force that I'm applying on the board, is it external or internal?
It's external, like you
Sir,
said earlier.
external, sir.
It's external. All of you say it is external. If I'm pushing the board, is the force external or internal?
The force applied by you on the board
On
is
the board.
external.
It's external. Okay. So again, let's get back to the previous example. If the man is pushing the box, under what condition this force is internal? If box and man are taken as system, right? And if only man is taken as system or box is taken as system, then this force is what? This is external force. So again, when I'm pushing the board, so we have not defined the system here. If I define the board to be system, then the force is external. If I define myself to be the system, even in that case, the force is external. But if I define myself and the board to be a system, then the force is internal. I hope it is clear. That's clear. So under what condition? So the force that I'm applying on the board can be external or internal depending on what I define as system. If I define board as system or myself as system, both the cases what will happen? The force would be external. But if I define myself and board together as system, then the force would be internal. I hope that's clear now. So the answer is so answer can be external or internal. So now let's try to summarize whatever we have discussed about internal or external force, right? So what defines whether a force is, or what decides whether a force is external or internal? I can say any force can be external or internal. A force can be, you can take down this. A force can be external or internal depending on what? Depending on the system considered. So how do I define a system? That that decides whether the force is external or internal. So any force can be considered as internal or external, unless and until I define a system. But once I define a system, then we have a specific rule. Like once I define this board to be a system, the force that I'm applying on the board is what? External force. So once a system is defined, what is external force? So external force is what? Force applied by the system or on the system. Both the forces are external forces. I hope it is clear. If I am considering myself a system, then if I push the board, that is external force. If the board pushes me, that's also external force. I hope this is clear. You can quickly scribble it down. So a force can be external or internal depending on the system considered. That's the first thing. Second thing, how do we define an external force? Once the system is defined, external force is what? Force applied by the system or on the system. So if you and your friend are two systems, you pushing your friend or your friend pushing you, both the forces are external force. Done?
But if both of us are pushing each other, then it is internal.
No. If both of you are pushing each other and both of you together are the system, then it is internal.
Oh, yeah. Okay. Yeah.
Okay? Yes. So now the next part. So we have defined what is an external force. Let's try to define what is an internal force. So can someone help me defining internal force? Because you understood what is external and opposite of external is internal. Can anyone, define what is an internal force? I can say force applied by one part of the system on another is internal force. So I'm just reframing your words, nothing more than that. So how do we define internal force? A force applied by one part of the system on another.
So internal forces are all, or can also be forces like which are exchanged by objects in the system.
Yes, forces exchange. If I consider, see, the whole universe as a system and every force that is coming is internal force. Got it? So if we consider our solar system as system, then every force that is applied between the planets or one person on another person on each planet, whatever, is an internal force. Unless and until we have another solar system which is applying force on our solar system. Okay, so I hope that's clear. Internal and external forces. Fine. So after that, let's redefine inertia. Before defining the system, we can't be sure whether a force is external or internal. But once the system is defined, force applied by the system or on the system is external, and force applied by one part of the system on another is internal. Fine. So we also call it as law of inertia, right? First law is also known as law of inertia. And what did we say? What is inertia? Inertia is, what is inertia? You've seen that inertia is what? Tendency of a system. Tendency of a system.
To resist, it is in its state of motion.
Oppose any change. Let's generalize it, then we'll go for each specific thing, right? What you said is right. So resist something. So resist motion or whatever, right? So what is the tendency of a system to oppose any change is called inertia. Got it? So this is inertia. Inertia, as we discussed in the earlier class, it can be, opposition to change in state of rest. So we call it as inertia of rest. Inertia of rest is what? It is opposition to change in state of rest. So if it is at rest, it wants to rest. It doesn't want to move from its original position. That's what is inertia of rest. Then we have something called inertia of motion. As Akshat said, what is inertia of motion? Opposition to change in state of uniform motion. State of uniform motion. So if the body is moving with a constant velocity, it wants to move with constant velocity. And the third thing, of course, which can be considered a part of this inertia of motion, we say inertia of direction. Now, what is inertia of direction? Yes. Now, the next important question, which I think we defined or we answered in the last class, what causes inertia? Let's try to investigate this. What is cause of inertia?
Mass causes inertia, according to what we discussed last class.
So we have discussed this last time. What is cause of inertia? It's difficult to move a body which is heavier than a body which is lighter, right? So that means what?
The more the mass, more the inertia.
More the mass, more is the inertia, right? So if mass is more, then inertia would be more. So what is cause of inertia? A very important thing. It is the mass of the body which is cause of inertia. Fine. So you can just write down that also. Inertia is, so what causes inertia? Mass is responsible for inertia. Greater the mass, greater is inertia. So it is difficult to move a body which is heavier than a body which is lower. In the same way, it is difficult to stop a body which is heavier than a body which is slower. Again, the same continues for inertia of direction. It's difficult to turn a body which is heavier than the one which is lighter. So in all these cases, inertia is the cause of, mass is cause of inertia.